This video will walk you through an example of applying the normal distribution. Now, I have an Excel spreadsheet open here for you, but there aren't any real Excel formulas that I can use in order to apply this. I'm just using Excel here in this case as a method to calculate. So in this example, a random variable is uniformly distributed between 5 and 27. We don't have to worry in the normal distribution about how things would potentially be written. Most of the questions are just going to come right out and give you that uniform, or say uniform distribution in there. So for the uniform distribution, you're going to get 2 points. We're going to call them A and B. A is going to be your lowest observation, and B is going to be your largest observation. So I'm going to record them here, A and B. And A is my smallest observation within the sample, and then B is my largest observation within the sample. So our first question here asks us, what is the expected value of the variable? I've copied here for you your equations as they appear on the formula sheet. So the expected value of the variable, we're just going to use this formula. E of x means expected value of x, our variable is x, is equal to A plus B divided by 2. So E of x is going to be equal to A plus B, and that quantity is going to be divided by 2. Now, obviously, you can do this just, using your own calculators, but remember, if you're going to do it in Excel, we have to put in the parentheses because Excel doesn't automatically recognize the order of operations there, and it would potentially just divide that B by 2. So the expected value there is 16. Next it asks, these are actually 2 separate questions. Let me put a space in there. Okay. Next it asks, what is the variance of the variable? So again, just applying that formula. So the variance of x is going to be equal to, my numerator here is b minus a, that quantity squared. So b minus a, that quantity squared. And then I want to take all of that and divide by 12. Why 12? That's the formula. Okay, so the variance there is going to be 40.33. If perchance you were asked for the standard deviation, you would just, if you're asked for the standard deviation, you would just take the square root of that number. Okay. Then we're going to move into some probabilities. So what is the probability that a random draw from the distribution will result in an observation of 14? So it's asking us specifically, what is the probability that x equals 14? Okay. Another way of saying this here is to apply this formula, f of x, where f of x is equal to the probability of a given x. So we have f of x is equal to 1 over b minus a for all x's between a and b. For anything else, it's going to be 0. So with the uniform probability distribution, you will have an equal probability between the interval of a and b. Outside of that, there is no possibility of it existing. So here we're looking at a single observation, a single variable observation within that mean, within that distribution. So 14 is between 5 and 27. So what's the probability of a single observation occurring within that interval? That's just going to be equal to this formula, equals 1 divided by the quantity b minus a. So for any given observation there that we might have, let's say it could be 5, 6, 7, 8, 9, 10, all the way up to 27, they all have an equal probability of occurrence of 4.55%. For any variable or observation greater than 27, the probability is 0. For any observation less than 5, the probability is 0. What is the probability that a random draw from the distribution results in an observation less than 12? So probability that x is less than 12. Okay, well that would be equal to the probability that x is essentially between 5 and 12. Now, why am I saying that? Because the probability that our observation is less than 5 is equal to 0. So another way of rewriting this would be, what is the probability that x is between 5 and 12? Because outside of that interval, the probability would be 0. So the way I would write this, I can essentially rewrite this to say that it's the probability that x is less than 12 minus the probability that x is greater than 5. And I have this in two separate steps here. That's a minus, not an equals. Okay, so again, just rewriting that as two separate steps so I can illustrate the math involved here. So what is the probability that x is greater than 12? So I would take my probability here of 4.55%, so 0.0455 times 12 minus that same probability times 5. Now, because we're doing this in Excel, we have to go in and put the stars in there to indicate our multiplication. Again, you would just be able to enter that normally into a calculator. So this is just something that must be done as a result of using Excel. And I come up here with a probability of roughly 32%. So that's the probability that x is less than 12 minus the probability that x is greater than 5, because that gives me the probability that x is between 5 and 12. Now, I did this as two separate calculations, so started with the probability that it's going to be less than 12 and subtracted off the probability that it's going to be greater than 5. But note here that probability is the same, so I could just factor out that probability, so that 0.0455, and multiply that times the difference between the upper and lower bounds that I have. So my upper and lower bounds here were then 12 minus 5. So this is just another way of rewriting that, and it will result in the same value, and that's just kind of a shortcut there that you could apply. Now I want to figure out what is the probability that a random variable, random draw from the distribution is greater than 20. So probability that x is greater than 20. That can also be rewritten to say what is the probability that x is between 20 and 27, because 27 is again the top range that I have there. So that in and of itself can be written as the probability that x is greater than 20, less than 27, but greater than 20. Okay, so I can apply my same shortcut methodology because it's applying that same logic there. So that would be equal to that same probability of 0.0455 times the difference between my effective upper and lower bound within that interval. So 27 minus 20. And that, ironically, just because of the spacing that I chose there, is going to give me that, that same value. Now, what if I can change this, instead of saying 20, I can say 25, just so you don't, assume that this is some kind of issue there, we're always going to get the same number. So I could just change this here to say 25. And then we would see that my probability does in fact change. So that was just, a result of the fact that I had picked those numbers. So just going through them again and showing you that you're not always going to get the same answer. But that's how we do our calculations.